Hello everyone, my name is Zaz Biela from Entertainment. Today we'll be doing calculus for grade 12. Okay, here we are required to determine f prime x from our first principle if f at x is equal to x cubed. Okay, so we just underline the keyword first principle. Okay. Since we are told that we have to find f prime of x from first principle, that means we have to use this formula, which is a limit as h approaches 0, f of x plus h minus f of x all over h. Okay, we know f at x, but we do not know f at x plus h. So let us try to find f at x plus h on a side. So f of x plus h is equal to x plus h to the power of 3, of which can be expanded x plus h, x plus h, x plus h. Okay, so from here we have x plus h. So when you say x times x, you get x squared. You say x times h, you get xh. You say h times x, you also get xh. H times h becomes h squared. Okay, so now we minus throughout. We want to get rid of brackets. So x times x becomes x to the power of 3. X times x h. Okay, this one. Okay, here. Okay, let us start by. Okay, let us continue with this one, so that here we also group like terms. So xh plus xh becomes 2xh plus h squared. So now we can eliminate a bracket. So x times x becomes x cubed. X times 2xh becomes 2x squared h. X times this one becomes x h squared. H times this one comes x squared h. H times this one becomes plus 2x h squared plus h cubed. Okay, so now let us look whether do we have like terms so that we add like terms. Okay, there's nothing with x cubed, it's only one x cubed. Okay, let us check. Let us check here. Okay, here we do have 2xh squared and we have xh squared. So meaning we can write 2xh squared, and this one also becomes 3x squared h plus h squared. H cube, not squared, but it is a cube. Okay, from here now we know f of x plus h is equal to this term. So meaning we go back to the formula for differentiation using first principle. So which becomes this equal to a limit as h tends to 0. So when I see f at x plus h, I can replace it with this entire equation. I can replace it with this. Okay? So meaning x, sorry, yeah, it's a cube. It's x cube plus, this one is 2 plus 2 plus 1, should be 3 here, not 2. 3, yeah, it's 1, 3, 3, and 1 coefficients, okay? So plus 3x h squared plus 3x squared h plus h cube, and then you minus f at x, and f at x was given to us to be equal to x cube. Okay. All over h. Okay. Still finding the limit as h tends to 0. So you see that this one and this one cancels. So we are left with 3x h squared plus 3x squared h plus h cube all over h. So a limit as h tends to 0. So we can take out the common factor here to be h. So we are left with 3x squared plus 3xh plus h squared, you divide by h. So h and h cancels. You are now left with the limit as h approaches 0. Here we have 3x squared plus xh, what's 3xh? Okay, write it correctly. It's 3xh plus h squared. So then you can let h now equal to 0. So here, when h is equal to 0, that means you'll be left with the 3x squared plus 3x times 0 plus 0 squared, which is equal to 3x squared. So f prime of x using first principle gives us 3x squared. Okay, moving forward, here we are required to determine the derivative of f at x being equal to 2x squared plus half x to the power 4 minus 3. Okay, so here what you are going to do is that f prime of x is equal to, okay, is 2 times 2 becomes 4 x, and then 2 minus 1 becomes x, of which becomes 1, plus 1 over 2 times 4, that one becomes 2x, and then 4 minus 1 to the power of 3. So we are done this one. Okay, let us look at number 3. Number 3, they are telling us here that if y is equal to into x squared minus 1 all squared, we are required to prove that delta y over delta x is equal to 12x to the power 5 multiplied by the square root of y if x is greater than 1. Okay. The first thing to do here, let us find the square root of y. So since we know that y is this one, meaning a square root of y will be equal to as square root of x to the power of 6 minus 1 so this one and this one will cancel, so a square root of y becomes x to the power of 6 minus 1. Okay, meaning whenever we come across something like this, we know that we can replace this with the square root of y. Okay, we do know y, but for simplicity, we have to expand this to make sure that it makes things easy for us to differentiate it. So y is equal to, we know that this one is being squared, meaning you can expand it as x to the power of 6 minus 1 times x to the power of 6 minus 1. Okay? When you multiply the two, you see that it has same basis. What to do is to add their exponent. So you end up having x, and 6 plus 6 is equal to 12. Okay? X to the power of 6 multiplied by minus 1 becomes minus x to the power of 6, and then you also minus x to the power of 6. So it becomes minus x to the power of 6 minus x to the power of 6. Minus 1 times 1, it becomes plus 1. So here we have x to the power of 12. These two, they give you minus 2x to the power of 6 plus 1, of which is y. Okay, so now you want to derive this. You want to find theta y over theta x, of which is, you say, an exponent multiplying the coefficient of x, of which is 1. So 12 times 1 becomes 12x, and on the exponent you subtract 1, you are remaining with 11, minus an exponent is 6, and the coefficient of x in this point is minus 2. So when you say minus 2 times 6, you get minus 12. X, and then when you say 6 minus 1, you get 5. And when you are differentiating a constant, you get 0. Meaning, here, if you can look carefully, we can factor out 12 x to the power of 5, and you see that since the exponent of this one is 11, meaning if you can write x to the power of 6, when you multiply the two, they are of same basis. The only thing to do is to add their exponent. You will get this 11. And for you to get this 12x to the power of 5, you have to multiply by 1. So now you see that this thing is equivalent to a square root of y, meaning we can replace this thing with the square root of y. Therefore, theta y over theta x is equal to 12x to the power of 5 multiplied by the square root of y. Finally, we managed to prove what we were required to prove. Okay, last but not least, here we are given f at x being equal to 2x to the power of 3 minus 2x squared plus 4x minus 1. Here we are required to determine the interval on which f is concave up, but they did not specify. In fact, there's something missing here. They should have been written that determine the interval of x on which f is a concave up. So here you can add of x. All right. So how do you find the concavity? A concavity is being found by deriving the given equation 2 times. So the first derivative gives you a stationary point, and the second derivative gives you a point of inflection, of which is the point where your graph change its concavity from being convex to from being concave up to concave down, or from being concave down to concave up. Okay, so here we find the first derivative of this. It becomes 2 times 3, it becomes 6x, and 3 minus 1 becomes 2, minus, when you say 2 times 2, you get 4x, and then when you say 2 minus 1, you get 1, plus a derivative of this one becomes 4. So now you have to find the second derivative. A second derivative will be equal to 6 times 2, it is 12x, and then 1 times 4, it becomes minus 4. Okay, so we know that a gradient at a point is equal to 0. So it becomes 0 is equal to 12x minus 4. Solving for x, you take minus 4 to the other side, so you have 12x being equal to 4, meaning you can divide both sides by 12. As the result, your value of x becomes 1 over 3. But 1 over 3 in this scenario is a critical point, is a point of inflection. That means it's a point where the graph has to change its concavity. But you don't know whether is it changing concave up or concave down. How do you find that the graph becomes concave up or concave down? Okay, let us start here. Okay, let us start here. All right. This is the real line. Okay. On the real line, what you know is that here we have 1 over 3. X is equal to 1 over 3 here. This is the point where x is equal to 1 over 3. And on this side, x is greater than 1 over 3. On the other side, x is less than 1 over 3. So for us to find the concavity where the graph is concave up, what we have to do, we have to take this critical point, we check values greater than a critical point, we plug them to this second differentiated equation, yeah, of which is f double prime. If we get a negative value, we know that, okay, that's where our graph is concave down. But if we get a positive value, that's where we know that, okay, our graph is now concave up. Okay, let us do this. Taking the value, you can take any value, arbitrary value greater than 1 over 3 or less than this one. Let me start by the value of x less than 1 over 3. I personally prefer using natural numbers because when working with fractions, maybe it might complicate things. So a number that is less than 1 over 3, how about I take 0? That means I let my x to be equal to 0, meaning f double prime of 0 is equal to, when I plug 0 here, it becomes 12 times 0, which is 0, minus 4, I get minus 4. Okay? Minus 4 minus 4, I know that minus 4 is less than 0. And then I take an arbitrary value of x also greater than 1 over 3. Let my x be equal to 1. But you can take any value of x that is greater than 1 over 3. It's not always the case that you have to take 1. So I'm going back also to my second derived equation, of which was this one. It was, let me go back to it. It was 12x minus 4. So it's 12x minus 4. So now I want to find second differentiation of x at the point where x equal to 1. So it becomes 12 times 1 minus 4, of which is what? It's 8. and my age is positive. So in this scenario, this one is greater than 0. Okay, so now I know the value of x, the values of x that will give me a positive um, second differentiation. So that means where x is greater than 1 over 3, that's where my graph is concave up. But here I'm required to find the interval. So the way of writing an interval is to say it's your x belonging to the set, but please make sure that you don't write a square bracket, but you write an open bracket, not close bracket, an open bracket, 1 over 3 up to infinity, meaning 1 over 3 is not included on the set of x values that you might use. Okay, that is all for today. I think this video will be will be benefitable to those who might need help in such a concept of calculus. Thank you very much. Looking forward to meet you in my second video.